Hi, I'm Dan with Family White TV, and this installment of Home Theater for the Masses is the second in the audio subset of the series on home theater sound. In this installment, I'll be talking about things you'll need to know when purchasing speakers for your home theater. Now, if you aren't familiar with home theater surround sound and what each speaker does, you'll want to see my video on surround sound. Now, first and foremost, I'll say that the speakers are the one thing you should try not to cheap out on. Now, sure, you can get some decent speakers for now, but try to resist the urge to get better speakers as a half step towards the speakers that you ultimately want. Speakers, unlike other electronic items in a home theater, do not become obsolete. A great set of speakers from 20 years ago is still a great set of speakers today, and they'll still be a great set of speakers 20 years from now unless somebody comes out with a radical new technology that fundamentally changes the audio reproduction. Now, in order to know what we should look for when buying a great set of speakers, we need to have a common reference. Do you ever wonder why home theater amplifiers have volumes that go from negative 120 all the way up to 0? Do you ever wonder why 0 dB on your volume meter is really loud? That's because 0 dB is our reference. In the past, there was no set standard for volume levels. Amplifiers would go up to 10. Then an enterprising amplifier company made one that goes one louder.
This is a top to what we use on stage, but it's very, very special because if you can see, the numbers all go to 11. Look, right across the board. 11, 11,
and most of
11,
the
and then
amps go up to 10.
Exactly.
Does that mean it's louder? Is it any louder?
Well, it's one louder, isn't it? It's not 10. One louder.
Why don't you just make 10 louder and make 10 be the top number and make that a little louder?
These go to 11.
So then later on, somebody makes an amplifier that goes up to 15, and then one that goes up to 100. But it's all meaningless because there was no set reference. Today we do have a reference. THX defines the reference level as 85 decibel average with 20 decibels of headroom. This gives us a peak level of 150 decibels, and with subwoofers the peak level is 115 dB. And so a properly calibrated receiver with the volume set to 0 will produce 105 dB of sound at the listening position and 115 dB from the subwoofer to the listening position. Now, to be clear, reference level is louder than most people care to watch movies at. I usually watch it around -6 to -9 dB on the volume knob. But ideally, our speakers should be capable of producing 105 decibels at the listening position. And so, with reference level defined, what do you look for in a great set of speakers? You look for frequency response, power handling, sensitivity, and build quality. When looking at home theater speakers, its frequency response is defined as the range of frequencies at which a speaker can reproduce audio, plus or minus 3 dB. For home theater speakers, you want them to have a range that starts at no greater than 80 Hz and goes all the way up to 20 kHz. Better speakers will go higher, and some audiophiles will argue that the way ultrasonic frequencies interact with audible frequencies matter, but for most of us 20 kHz is good enough. On the low end, 80 Hz is the highest our speakers should roll off at. Speakers that can play lower are desirable. My RF72s, for example, are rated to go all the way down to 30 Hz. The reason we want them to be able to reproduce sound down to 80 Hz is because that's where our subwoofer should take over, per the THX specification. This is also known as the crossover frequency. Now, if you have larger speakers that can play lower than 80 Hz, you can cross the subwoofer over at lower frequencies. Mine, for example, I cross over at 40 Hz for the mains and 60 Hz for the surrounds. Now, if you enjoy listening to music and are a purist, a set of front speakers that can play as low as you can afford is desirable. When you set your AV receiver to pure audio or direct, the receiver does as little processing to the sound as possible so that you get the most pure, accurate sound possible at the speakers. This means the receiver will also not redirect low-frequency sounds to the subwoofer, and so larger front speakers are desirable in this case. Now, the reason you want to cross over at frequencies no higher than 80 Hz is because audio gains locality above 80 Hz. What this means is that if you have a speaker playing a sound that's below 80 Hz, that's low enough that your ears can't tell what direction the sound's coming from. At above 80 Hz, you can start to perceive which direction sound is coming from. The reason this is important is because a subwoofer's ideal location is usually not going to be right next to our front speakers. If you have one subwoofer, it is usually going to be in a corner or perhaps next to a sofa or behind your sofa. Now, I'll go over subwoofer placement in the subwoofer video, but suffice it to say that our subwoofer will rarely be next to our main speakers. What this means for us is if you have your main speakers crossed over to the subwoofer too high, you'll start to hear audio coming from the direction of your subwoofer. This can be distracting if you have somebody with a deep voice talking on a screen. If you have a crossover set at 150 Hz, for example, you'll hear part of that voice coming from the direction of the subwoofer. You'll also hear other sounds that should be coming from your main speakers coming from the direction of your subwoofer instead. This is the downfall of lifestyle audio systems, which are speaker systems with really small, easy-to-hide speakers. Small speakers are physically incapable of reproducing low frequencies anywhere reference levels or even just normal listening levels. And so systems with small speakers need to be crossed over at higher frequencies. And this includes speakers made by a certain company that I won't talk about because I don't want to be sued. If you do want to hear about this speaker company, just do a search on the AVS forum. Now we're going to look at a speaker's sensitivity. We need to know how sensitive a speaker is so that we know how much power we need to put to it to get it to play at our desired volume. A speaker's sensitivity is defined as how much sound it will put out as measured from 1 meter away when fed a 1 kilohertz sine wave at 1 watt. And in the specification, sometimes this is listed as 2.83 volts. So now we need to do some math, and don't worry, I'll do it for you. Let's say we have a speaker with a sensitivity rating of 93 decibels. That means when we feed the speaker with 1 watt of power, we will get 93 decibels of sound 1 meter away. However, we want to get to 105 decibels. The way audio works, we need to double power to gain 3 decibels. And so to get to 96 decibels, we need 2 watts. To get to 99 decibels, we need 4 watts. To get to 102 decibels, we need 8 watts. And to get to 105 decibels, we need 16 watts. Now, we're not done with this yet, because we need to take into account our seating distance. Most of us are going to sit farther away than 1 meter from our speakers, and so we need to calculate how loud the speaker will play at our listening position. In order to do that, there is a big scary thing called the inverse square law. I'll spare you the math, but the end result is that every time you double the distance, you lose 6 decibels. And so if we hear 105 decibels at 1 meter away, we will hear 99 decibels 2 meters away. And at 4 meters away, we will hear 93 decibels. And so if our listening position is 4 meters away, or 13.1234 feet away from our speaker, we need to increase the power to get it back up to our desired 105 decibel reference level. And so from our previous formula, we got 105 decibels at 1 meter with 16 watts of power. That translates to 93 decibels at 4 meters with 16 watts of power. So let's get back up to 105 dB. So 93 decibels at 16 watts, add 3 decibels, 96 at 32 watts, 99 at 64 watts, 102 at 128 watts, and 105 decibels at 256 watts. And so we see that at a distance of 4 meters or 13 feet, we need to feed the speaker with 256 watts of power to achieve our reference level. This is how we determine how much power handling our speaker needs to have. Now, there are inverse square law calculators that you can use to determine the exact amount of power you need. My seating distance is about 9 feet from my speakers, which is about 2.8 meters. In our example above, I would need 128 watts to get to 105 decibels at the listening position.
Now, I realize that might be a little bit much all at once, so let me just walk you through this really simply. So what you want to do here is first, you want to put in what your seating distance is to your speakers. So in my case, 9 feet. Now you want to put in your desired listening level down here, which, since we want to get to reference, 105 dB. Now we need to know, we're going to use our sensitivity of the speaker to calculate this. So our sensitivity is measured at 1 meter, so we put 1 meter up here. And so we see that we need to measure or we need to get 113.7 decibels. We'll round up to 114 decibels at 1 meter away in order to get our 105 decibels at 9 feet away. Now, the way we use our speaker sensitivity specification to find out how much power we need is we put in the measured sensitivity at 1 meter away, which is going to be 1 watt. And then we just start doing the math. So we add 3 dB, 2 watts. We add 3 more. And we just keep doing this until we get to the level that we need up here. So we round up to 114 decibels. We find out that we need 128 watts of power to achieve 114 decibels, which will give us 105 decibels at 9 feet away. So you can use this calculator, just put in whatever seating distance you want. So let's say if you had 12 feet, then you got to change this back to 105 dB. And so you need 116 dB at 1 meter away in order to get 105 dB at 12 feet away. And you just go back here. So we'll add 3 more. So 117 dB, 256 watts of power needed for that seating distance. So that's how you can do it.
Now, speakers with a higher sensitivity rating are more desirable. For example, my Klipsch RF72 speakers are rated at 101 decibels of sensitivity. What that means is I need to feed them a lot less power than speakers rated at 93 decibels of sensitivity. This way I can get much louder sound without having to buy a huge amplifier. And so now let's talk about a speaker's power handling. This is something you want to look for when buying speakers. Now there is one thing you want to watch out for when buying speakers. Some manufacturers will just put the peak power rating in big numbers because big numbers look good. But you want to dig a little deeper and find the speaker's continuous power rating. Peak power is how much power a speaker can take for a brief moment of time without suffering damage. Continuous power is how much power a speaker can take over long periods of time. Now, since 105 decibels is our peak reference level and is generally not going to be a level that will play continuously in a movie soundtrack, you could take this into consideration when selecting a set of speakers. However, I prefer to have speakers that have headroom. Headroom is how much power a speaker can take beyond what you expect of it. For example, if I feed my speakers 150 watts to achieve my desired listening level, and the speaker is rated at 600 watts, I have 450 watts of headroom, which equates to about 6 dB of headroom. Headroom does 2 things. It protects your speaker in case you or somebody else turns the volume up too high and feeds it more power than normal, and better AVRs will allow you to set a maximum volume limit. But it also ensures that your speaker will play distortion-free sound and will do so comfortably. Now, what do I mean by playing sound comfortably? Well, for example, let's say you have a car that has a top speed of 75 miles per hour. If you get on the highway, you'll get to 75 miles an hour, but the car will be straining because it's being run at its limit. If, however, you get a car that has a top speed of 150 miles an hour and all you do is drive at 75 miles an hour, then the car is not going to have any problems and it's not going to be straining. Speakers are the same way. If you get a speaker and play it at its limit, it can do so, but it'll be straining to do so, and that may be causing audible distortion. But if you get a speaker that can play louder than you want it to, it will easily play at your desired listening level without distortion, assuming your amplifier can provide the required power. Now, I will say that the ability to play at reference levels can be expensive, mainly because you need an amplifier capable of pushing enough power to get to reference level, or you need speakers that are sensitive enough to play at reference level, which can also be expensive. But keep in mind that reference levels are generally really loud. Negative 6 dB below reference level is still a nice loud listening level, and so in order to not break the bank, you can take this into account when selecting speakers and amplifiers. So reference level is a nice goal, but most people will be perfectly happy 6 decibels below reference. So now we know how loud and how much power our speakers need to take. So next is build quality. Build quality has 2 aspects, construction and appearance. A well-constructed speaker is going to be internally braced. Of course, most stores will frown on you removing drivers from the speaker cabinet to take a look inside, but you can easily determine the internal construction using the knock test. Just knock on the speaker. A well-built speaker will not sound overly hollow, whereas a cheaper speaker will sound like an empty wood box. This is important because as a speaker produces sound, its cabinet will vibrate in reaction to the sound and add undesirable coloration to the sound. Internal bracing minimizes this so that the cabinet does not color the sound. The other aspect of build quality is appearance. Now, cheaper speakers will have vinyl coverings, which can be easily marred. Better speakers will have real wood veneers. Higher-end speakers may also offer various finishes such as piano black gloss, cherry, walnut, etc. Ultimately, how good a speaker needs to look is up to you and probably your significant other also. However, if you have an acoustically transparent screen and you're going to be putting your speakers behind the screen, one option some people have gone with is to get commercial speakers. Commercial speakers can be less expensive than speakers designed to be in the home because they aren't finished. They aren't made to look nice, they're just made to perform well. And so you can put some commercial speakers behind your screen and it won't look ugly because you won't see them because they're behind your screen. Now, there is something you need to be aware of when auditioning speakers. If you're doing comparisons of different speakers in a store, there is a psychoacoustic phenomenon that causes us to believe that louder speakers sound better. What this means is if you're doing an A-B comparison of two different speakers, you'll almost always believe that the louder one sounds better. For this reason, you should ideally use a dB meter or decibel meter to level match the speakers you're comparing. However, this may not be possible unless the salesman is willing to let you tinker around with the setup. Aside from that, the best thing you can do when auditioning speakers is to bring some material you're familiar with for critical listening sessions. Also, don't listen in noisy showrooms if at all possible. Finally, consider the room you're listening in, or better yet, get an in-home audition if possible. If you can't get an in-home audition, then take into consideration the kind of room the speaker's in and think about whether or not the room closely resembles the room in your own home. The room a speaker is in can have a large effect on the sound of the speaker, and so a speaker that sounds good in a store can sound bad in your room at home, or a speaker that sounds bad in a store may sound good at home. At this point, I can't help but remember a store I visited that had a Klipsch THX Ultra 2 surround sound system in its own room. The speakers sounded horrible because the room was horrible. There were solid walls, a glass back wall, a hard ceiling, and a hard floor with a small carpet with a sofa in the center of it. This made the room a veritable echo chamber and effectively drowned out the sound of the system with reflected noise. I'm tempted to believe the manager of the store actually did not want to sell these speakers because the room could not have been worse. So take into consideration the room that the speaker you're auditioning is in. Think about if it's kind of similar to your room, if it's carpeted or not, if there's furniture in the room that's helping to reflect the noise, if it sounds similar to the room that you're going to be putting them in your own home. If the room is very echoey, that's really going to affect the sound of the speakers. Or if the room is overly dead, that may also affect the sound of your speakers if you're planning to put them in a room in your home that is very live sounding. That is, it has a lot of hard surfaces and maybe a bit more echoes than normal. So those are the important specifications that you need to know about in order to choose the best speaker for your situation. Frequency response, sensitivity, power handling, and build quality. Now, one excellent resource I want you to know about specifically is the website audioholics.com. They are a no BS website that will give you the straight truth on all sorts of audio topics and will be invaluable in your quest for home theater bliss. Now, as some videos appear over there, I'll tell you that the next video is most likely going to be on subwoofers. If you have any questions, please feel free to ask them and I'd be happy to answer them in the comments below, and thanks for watching.